Hello all, myself I am N.G.P. I am working as an assistant professor in Department of Chemistry at N.G.P Arts and Science College, Coimbatore. In this video, I'm going to discuss the topic called Basics of Nanochemistry. Here, we are discussing about what is nanochemistry, what are nanomaterials, properties of nanomaterials, types of nanomaterials, and classification of nanomaterials based with their dimensions. What is nanochemistry? It is the combination of chemistry and nanoscience. It is associated with synthesis of building blocks which are dependent on size, surface, shape, and different properties. So this is nanochemistry, which is somewhat related to synthesis of nanoparticles based with the ideology of nanoscience. What are nanomaterials? It can be defined as materials possessing at minimum one external dimension measuring 1 to 100 nanometer. The definition given by the European Commission states that the particle size of at least half of the particles in the number of size distribution must measure 100 nanometer or below. What are nanomaterials? The nanomaterials should have the size 100 or below 100 are called nanomaterials. These are all some examples for nanomaterials. Especially these examples from carbon-based nanomaterials. Diamond, fullerene, carbon nanotubes, graphite, graphene, graphene oxide, carbon dots. These are all some important examples for carbon-based nanomaterials. Next, what are all the physical properties of nanomaterials? They should have some size, shape, specific surface area, aspect ratio. Then agglomeration or aggregation rate should have any one of these two property. Then it has some size distribution, surface morphology or topography. So these two properties are somewhat related with their surface related activities. Then structure including crystallinity and defect structure. So the structure based activity is very important to understand their physical studies and also chemical studies. If the structure has any defect, then the property is not exactly matched with your original materials. So that's why the structure is very important. Then solubility. Either your carbon nanomaterials solved in water or fat related materials. So the solubility is very important. Chemical properties. Structure formula or molecular structure is very important for their prediction. Then composition of nanomaterials. It should have some particular composite. It may be included with degree of purity known as impurities or additives. Either your materials contacted with any impurities or additives which will be essential category for the confirmation of purity. So the purity is very important to confirm the activity or property of my nanomaterial. Then phase identity. What kind of phase is responsible for the nanomaterial? Then surface chemistry. The properties related with their surface activity are called surface properties. We have composition, charge, tension, reactive sites, physical structure, photocatalytic properties, and their zeta potential. So these are all the important surface properties which should have confirmed the property of your nanomaterials. Then hydrophilicity or lipophilicity. As I said in the previous slide, philicity is very important. I mean solubility is very important. Either our nanomaterial dissolved in hydrogen, I mean water, otherwise it is dissolved in the lipids called fat. Then types of nanomaterials. We have four types of nanomaterials. One is carbon based, second one metal based, third one dendrimerous, and fourth one related with other kind of materials. When you are taking carbon based, we have fullerene, carbon nanotubes. In carbon nanotubes, we have two types, single walled carbon nanotube and multi walled carbon nanotubes. Then graphene, carbon dots, at last nano diamonds. So these are all the some examples for carbon based nanomaterials. Then metal based nanomaterials. So we have different kind of metal related nanoparticles. For example, silver nanoparticles, gold nanoparticles, ruthenium nanoparticles, platinum nanoparticles, palladiums, then copper related nanoparticles, iron related nanoparticles. Almost all the metal has the property of nano. Then dendrimas. So dendrimas which would have formulated by some structural variation. For example, each and every kind of nanomaterial of dendrimer has core region, branching region, at last hydrophilic terminal. So the hydrophilic terminal is very important for the completion of the dendrimer. Then fourth type is composites. So composite, each and every kind of material has the ability to form a network related arrangement. So that particular network related arrangement of nanomaterials present in this category, we are saying it is nano composites. The next one, classification. So we have different kind of classification on nanomaterials, but here we are discussing about classification based on dimensions. So dimension is very important for the prediction of nanomaterials. We have four different kind of dimensions. One is 0 dimensional, 1 dimensional, 2 dimensional, 3 dimensional. In 0 dimensional, all dimensions at nanoscale. For example, nanoparticles present in the 0 dimensional value. The best example is quantum dots. Then 1 dimensional. For 1 dimensional structure, we have 2 dimensional at a nanoscale. For example, X and Y. Other dimension is not present in the dimensional area. The examples for this 1 dimensional arrangement is nanowires, nanorods, and nanotubes. And third type is 2 dimensional arrangement, 1 dimension at nanoscale. Other 2 dimensions are not present in the layer. We have nanocoatings and nanofilms. For 3 dimensional arrangement, we have more examples, especially in 3 dimensional arrangement. Almost all the materials present in particular category. Then 0 dimensional nanomaterials. The materials wherein all the dimensions are measured within the nanoscale, which means no dimensions or 0 dimension are larger than 100 nanometer. The most common representation of 0 dimensional nanomaterials are nanoparticles. See, we have metal related nanoparticles, we have quantum dots. So these are all the examples for 0 dimensional nanomaterials. It can be amorphous or crystalline. It has single crystalline or polycrystalline. It composed of single or multi-chemical elements. It exhibits various shapes and forms. Exist individually or incorporated in a matrix. It can be metallic, ceramic, or polymeric. See the examples. This example for 0 dimensional nanomaterial. Then 1 dimensional nanomaterials. 1 dimension that is outside the nanoscale. This leads to needle-like shaped nanomaterials. 1 dimensional materials includes nanotubes, nanorods, and nanowires. See the structural arrangement. It is an example for nanowire-like structure. It can be amorphous or crystalline. It has single crystalline or polycrystalline. Chemically pure or impure. Standalone materials are embedded within another medium. It has metallic, ceramic, or polymeric properties. Then, third type is two-dimensional materials. Two of the dimensions are not confined to the nanoscale. 2D nanomaterials exhibit plate-like shapes. Two-dimensional nanomaterials include nanofilms, nanolayers, and nanocoatings. See, this is an example for platinum coated with copper nanofilm. It has 100 nanometer range approximately. It can be amorphous or crystalline, made up of various chemical compositions, used as a single layer or multi-layer structures, deposited on a substrate because it has layer-like arrangement. It is integrated in a surrounding matrix material. It has metallic, ceramic, or polymeric materials. At last, the final one is three-dimensional materials. Bulk nanomaterials are materials that are not confined to the nanoscale. in any dimensions. We don't have any separate specification for this bulk nanomaterials. These materials are thus characterized by having 3 arbitrary dimensions above 100 nanometer. These materials possess a nanocrystalline structure, are involved in the presence of features at the nanoscale. In terms of nanocrystalline structure, bulk nanomaterials can be composed of multiple arrangement of nano-size crystals, most typically in different orientations. Then, with respect to the presence of features at the nanoscale, three-dimensional materials can contain dispersions of nanoparticles, bundles of nanowires, and nanotubes, as well as multi-nano layers. So these are all the 4 important nanomaterials present in the dimension-based classification. Last, in the present video, we discussed concept of nanochemistry, nanomaterials and their types, and classification of nanomaterials. Thank you.